Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning everyone. Nice to meet you all. Today inshallah we will start to complete our second video in finishing Cambridge International AS and A-Level Chemistry Paper Multiple Choice Paper 1 number 97/1/12 May June 2019. In the first video we finished answering questions from number 1 up to question number 10. Now we will start to complete questions from question number 11 up to question number 20. We will start together with question number 11, which row is an example of heterogeneous catalysts. At first, we must know what is the difference between homogeneous and heterogeneous catalyst. Homogeneous catalyst, it is catalyst in the same phase as the substance reacting. It is a substance in the same phase of reactants. For example, if I will react solutions, my catalyst will be solution. If I want to react gases, I will add gaseous catalyst. And heterogeneous catalyst, it is catalyst in a different phase. For example, if our reactants are in liquid phase, our catalyst will be in the solid phase or in the gaseous phase. So it is known as heterogeneous catalyst. According to the definition of homogeneous catalyst and heterogeneous catalyst, we must know how to answer the following questions. Number 1, A, esterification reaction and our catalyst is sulfuric acid. Esterification reaction, it is one reaction between carboxylic acid and alcohol. Reaction between carboxylic acids and alcohols will form water and ester. And catalyst used is sulfuric acid. It is our catalyst. So we are reacting solutions with aqueous catalyst. So it is homogeneous catalyst. The second one, the contact process by using divanadium pentaoxide. Divanadium pentaoxide, it is one of transition metals oxides. It is in the solid state. In the contact process, we will react sulfur dioxide plus oxygen to form sulfur trioxide. It is one of gaseous reactants by using solid catalyst. So it is heterogeneous catalyst. A third solution or third choice, we can say destruction of ozone layer. Ozone layer consists of O3. O3 is oxygen. We react with chlorine radical in the gaseous form also to form the destructive of ozone and form oxygen plus oxygen radical. So it is gaseous catalyst with gaseous reactants, so we have homogeneous catalyst. The last choice, atmospheric formation of sulfur trioxide. Atmospheric formation of sulfur trioxide is gas by using nitrogen dioxide. Nitrogen dioxide is also gas, so we have gaseous. So we have homogeneous catalyst. So at first you must know the difference between homogeneous and heterogeneous catalyst. Next question, question number 12. Element Q readily oxidizes in air. The oxide produced reacts with water to form a solution of very low pH, where element Q could be found in the periodic table. We will start to check each one of the choices. First choice, period 2, group 1. Period 2, group 1, we are talking about lithium. Lithium is metal. Metal oxides are basic oxides. pH of basic oxides is more than 7. Number 2. Group 14, it is non-metal, carbon. Carbon will form carbonic acid. Carbonic acid is weak acid. Group 3, Element 14. It is non-metal. It is a silicon. Number 4. Period 3, group 15, we are talking about non-metal. Phosphorus. Phosphorus is non-metal. Its oxide dissolves in water to form phosphoric acid. Phosphoric acid pH is the lowest pH in the following elements. So our best choice is phosphorus with low pH. It's okay. So just we are comparing between different elements, oxides, and expected pH for each one. Of course, as we go to the right in the periodic table, we are talking about non-metals. Non-metals oxides are acidic oxides. Its pH is less than 7. As we go to the right, the pH of the acid formed will decrease. So the acid will be more stronger. Question number 13. The 8 elements sodium to argon are in the same period of the periodic table. The equation corresponding to the first ionization energy is shown. X gas will lose 1 electron to form X plus gas plus 1 electron. For which of these 8 elements is the electron in this equation removed from a field orbital? So we are talking about field orbital electrons. Field orbitals electrons, we can talk about s orbital, px, py, or pz. We will start to make electronic configuration of the following elements, of the elements of our choices. At first, we are looking for S2, PX2, or PY2, or PZ2. We start with magnesium Mg1s2 to S2 to P6, 3s2. Of course, it is field orbital. Number 2, aluminium Al13, 1s2 to S2 to P6, 3s2, 3px1. It is not field orbital, so it is cancelled. Silicon Si14, 1s2 to S2 to P6, 3s2, 3px1, 3py1. Take care when we start to fill p orbitals, we start to fill them individually. px1, py1, pz1. If we have extra electrons, we will start to double the electrons in p orbitals step by step. px2, py2, pz2. So we have silicon is 1s2 to S2 to P6, 3s2, 3px1, 3py1. It is wrong. Phosphorus P15, 1s2 to S2, 2p6, 3s2, 3px1, 3py1, 3pz1. So all the orbitals of p orbitals are single field or not completely filled. They are half filled orbitals. Sulfur orbitals 1s2 to S2 2p6, 3s2, 3px2, 3py1, 3pz1. px orbital is completely filled, so removing any electron will be from px2 orbital. It is our correct choice. Chlorine 1s2 to S2 2p6, 3s2, 3px2, 3py2, 3pz1. So removing electrons will be from py2. It is completely filled orbital. At last, argon Ar, of course, it is saturated 1s2 to S2 to P6, 3s2, 3px2, 3py2, 3pz2. So removing electrons will be from completely filled orbitals. So our correct choice will be magnesium, sulfur, chlorine, and argon. Because in magnesium we will lose one electron from completely filled s orbital. In sulfur we will remove one electron from completely filled px orbital. In the case of chlorine, we will remove one electron from completely filled py orbital. And at last, in argon, we will remove one electron from completely filled pz orbital. Question number 14. Elements D and E are both in period 3. Element D has the smallest atomic radius in period 3. At first, we must memorize that as we go up right, the atomic radius will decrease. As we go to the right in the period, the atomic radius will decrease. Why the atomic radius will decrease? Because the number of protons inside our nucleus will increase. As the number of protons will increase, the ability of nucleus to attract the outer shell electrons will increase. So our atomic radius will decrease. The element in period 3 with the smallest atomic radius, of course, we are talking about halogens. We are talking about chlorine. Chlorine is the smallest atomic radius in period 3. There are only two elements in period 3 which have a lower melting point than element E. Element D and element E react together to form compound L. Of course, we are sure that we are talking about element chlorine. The second element, we have only two elements with less melting point. So we must cancel magnesium chloride and take phosphorus chloride. As if we start to study the melting point of elements gradually, at first we have sodium. As we go to right, sodium bond is metallic bond. The melting point will increase for magnesium, and for aluminium it will be higher. Silicon, we will have high and high melting point. Why we will have high and high melting point and boiling point? Because the silicon can form macrocovalent compounds. Then we have a very large drop to convert from macrocovalent compounds to simple covalent compounds. So the phosphorus melting point and boiling point is low. From phosphorus to sulfur, we are talking about melting point in the same range, or sulfur is quite more than phosphorus. Chlorine is lower because we have diatomic gaseous molecule. Argon, it is very low melting and boiling point. We are talking about noble gases. Noble gases are monoatomic molecules. So, of course, our best choice will be phosphorus chloride, PCl3. Question number 15. How many of the following solutions, when added to separate portions of magnesium sulfate solution, produce a white precipitate? We have different choices. At first, hydrochloric acid. Hydrochloric acid reacts with magnesium sulfate will form magnesium chloride plus sulfuric acid. Magnesium chloride is soluble in water. Second one, barium nitrate plus magnesium sulfate. Barium nitrate plus magnesium sulfate will form barium sulfate. Barium sulfate is insoluble in water, so we will have insoluble precipitate in our solution. Plus magnesium nitrate. Magnesium nitrate is soluble in water. Magnesium sulfate plus ammonium hydroxide will form magnesium hydroxide. Magnesium hydroxide is milky solution plus ammonium sulfate. So we have magnesium hydroxide milky solution, so it is insoluble in water. The same in the case of magnesium sulfate reaction plus ammonium carbonate will form magnesium hydroxide plus ammonium sulfate plus carbon dioxide. Magnesium hydroxide is milky solution. So we are talking about 3 solutions will form precipitate, will produce white precipitate. Our solution which will form white precipitate are ammonia as it will form barium sulfate. Barium sulfate is white precipitate. Second one is ammonium carbonate as it will form magnesium hydroxide milky solution. And barium nitrate, it will form magnesium hydroxide also is milky solutions. So we have 3 choices will form white precipitate. Question number 16. A white solid Z is insoluble in water. A sample of Z is heated with a benzene burner until there is no further change. When the residue is shaken with water, a solution is formed with no solid remaining. Which could Z be? At first, Z is soluble in water. Most of carbonates, we can say all of carbonates are insoluble in water. As the carbonates are insoluble in water, so we will cancel magnesium carbonate MgCO3 and barium carbonate BaCO3, it is cancelled. Number 2. We still have magnesium nitrate and barium nitrate. We will start to make heating, we will start to make decomposition, thermal decomposition reaction. Magnesium nitrate decomposition will form magnesium oxide plus nitrogen dioxide plus oxygen. Magnesium oxide is insoluble in water. Barium nitrate, we will heat it, it will form barium oxide plus nitrogen dioxide plus oxygen. Barium oxide is quite soluble in water. Take care. We have force of attraction between the atoms of group 2, like in magnesium and barium and the oxygen element. As the atomic radius of the element decreases, the ability to have strong interaction between the element and its oxide will increase. So we have extra interaction between magnesium and oxygen in magnesium oxide. Its type of interaction is greater than the force of attraction between barium atom of large atomic radius, of large atomic size, and oxygen in barium oxide. So solubility of the oxides will increase as we go down. So the best choice for the solubility in water will be for barium nitrate. After heating, as it will form barium oxide, it is quite soluble in water and its solubility is higher than magnesium oxide. Okay, now we will transfer to question 17. An excess of chlorine was bubbled into 100 centimeter cubic of hot 6 mole per decimeter cubic sodium hydroxide. How many moles of sodium chloride would be produced in the reaction? To solve this question, you must know the equation for the reaction between chlorine and sodium hydroxide. When chlorine reacts with sodium hydroxide, we will have 5 moles of sodium chloride plus 1 mole of NaClO3 plus 3 molecules of water. So we will have sodium chloride, sodium chlorate, and water. The balanced equation is essential to solve this question. As we are talking about number of moles of chlorine will react with number of moles of sodium hydroxide to form a specific number of moles of sodium chloride and sodium chlorate and 3 moles of water. We have specific information in our reaction. Our volume is 100 centimeter cubic of the sodium hydroxide solution. and its concentration is 6 mole per decimeter cubic. Of course, we want to calculate number of moles, N equals CV, concentration times the volume. So we have 100 centimeter cubic. We want to convert it into decimeter cubic by dividing over 1000 times our concentration, 6 mole per decimeter cubic. So our number of moles is 0.6 mole. If we start our chemical reaction, each 3 moles of chlorine will react with 6 moles of sodium hydroxide to form 5 moles of sodium chloride, 1 mole of sodium chlorate, and 3 moles of water. So, from the equation we can say that each 6 moles of sodium hydroxide will produce 5 moles of sodium chloride. Each 0.6 moles of sodium hydroxide will produce 0.5 mole of sodium chloride. So our correct answer, of course, is 0.5. Question number 18. Ammonia sulfate and ammonia nitrate are used as fertilizers. These salts have different percentage by mass of nitrogen. They have the same effect as each other on the pH of wet neutral soil. Which row is correct? At first, we want to know which one of ammonium sulfate or ammonium nitrate will have higher percentage of nitrogen per mass. To have the higher percentage or to calculate the percentage of nitrogen by mass, just we want to divide the mass of nitrogen atoms inside your molecule divided by the total relative molecular mass of the molecule. So, to calculate the higher percentage of nitrogen by mass, percentage of nitrogen in ammonium nitrate, we have 2 nitrogen atoms, and the molecular atomic relative atomic mass for nitrogen is 14. 2 times 14 equal 28, divided by total relative molecular mass of ammonium nitrate. So, the percentage of nitrogen ammonium nitrate is 0.35. Percentage of nitrogen in ammonium sulfate also we have 2 nitrogen atoms. Between the brackets we have NH2. So we have 2 nitrogen atoms. The relative atomic mass for each nitrogen atom is 14. 2 times 14 equal 28. 28 divided by total relative molecular mass of ammonium sulfate. So we have 0.21875. So the highest percentage in nitrogen in ammonium nitrate, not ammonium sulfate. It is the first choice. Second one, we still don't know if the pH of the soil will increase or decrease. As general information, all ammonium fertilizers can decrease the pH of the soil. All ammonium fertilizers can decrease the pH of the soil, as they can release hydrogen ion. Hydrogen ion is responsible for the acidity of the soil. So pH will decrease except if you add limestone or calcium hydroxide or calcium oxide, as all of these compounds are basic compounds. So it will increase the pH of the soil, won't decrease it. Okay? Question 19. Which reaction gives a product that is an amphoteric pollutant causing acid rain? We know that the main factors can cause acid rain are sulfur oxides, nitrogen oxides are the main causes for acidic rain. In the first equation, we react magnesium plus sulfur dioxide to form magnesium sulfide plus magnesium oxide. They are solids. We don't have any gases. Next question, we react ammonium sulfate plus calcium hydroxide to form ammonia gas to form calcium sulfate solid plus water. Ammonia gas is not responsible for the acidic rain. We are talking about nitrogen oxides. Manganese ion plus sulfur dioxide plus water will form manganese plus the hydrogen plus sulfur oxides. It is not the main cause. And if it is one cause of acidic rain, we are looking for the best choice. Take care, it is oxidized, so it is in solution. It is in aqueous form, not in gaseous form. So it isn't one of gases responsible for acid rain. Last choice, ferric sulfate, FeSO4, will form ferric oxide plus sulfur dioxide plus sulfur trioxide. So we have two different types of sulfur oxides. We have sulfur dioxide plus sulfur trioxide. Of course, they are gases mainly responsible for acidic rains. So our best choice is D, as we have sulfur dioxide and sulfur trioxide. All the other choices we have solids or liquids. Okay, next question. 3-methyl-but1-ene can undergo different types of reaction. Reaction 1, as you can see. Reaction 2, as you can see. Which row correctly identify the reaction type? At first, we will speak about reaction 1. The main difference between the first compound and the second compound is the double bond. We have double bond in the first one, and we have saturated compound in the second one. So during the chemical reaction, we add hydrogen. We convert unsaturated compound, alkene, into saturated compound. Adding hydrogen in any chemical reaction is known as reduction. Adding hydrogen is reduction. Adding oxygen is oxidation. Removing hydrogen is oxidation. Second part of reaction. We have double bond, it is broken, and we start to add 2 chlorine atoms. As we add 2 chlorine atoms, we are talking about type of addition reaction. In the following picture, we can see the mechanism of the chemical reaction. Double bond is highly charged. Double bond is electron rich, so it will work as nucleophile. The effect of double bond will attack on the chlorine atom, so it will make unequal distribution of the covalent bond electrons in the chlorine molecule. So the electrons of chlorine covalent bond will shift it to the other chlorine atom, and we will break the single bond between the 2 chlorine atoms heterolytically. By heterolytic fission of the single covalent bond between the 2 chlorine atoms, we will have chlorine atom converted into chlorine ion. So we will have chlorine ion partially negative, carrying excessive electrons, works as nucleophile, and the other chlorine will convert it into electrophile. It will have decrease of electrons. So we will have chlorine will attach it to our compound, and we will have carbon cation. We will have carbon carrying positive charge. The other chlorine atom contains excessive electrons, so it will attack the carbon cation, and we will have 1 and 2 dichloroethane. Take care, the addition will be to 2 different carbon atoms, not on the same carbon atom, as it is addition reaction. It is the mechanism of the addition reaction of chlorine to ethene. But we want to know what is the difference between nucleophilic substitution and electrophilic substitution. Nucleophilic substitution involves displacement of a leaving group by a nucleophile. Displacement of a leaving group by a nucleophile. Displacement of functional group by nucleophile. In our reaction, chlorine is electrophile, not nucleophile. So we can say that the electrophilic substitution reaction involves the displacement of functional group by electrophile. In our reaction, chlorine lost its one electron and converted into chlorine positively charged. So it is electrophile. It likes electrons. So it will carry a positive charge. And we have chlorine works as electrophile. So in our reaction, we can say that we have reduction reaction and it is electrophilic addition reaction. In the next video, inshallah, we will complete from question 21 up to question 30. I hope that you understand this part. You have more information from the video. See you soon. Don't forget to make share and subscribe and comment for our channel. See you later. Assalamu alaikum.